Hello Year 11. This is another example from the textbook that I thought I'd just try and spell out again in a video presentation. Now it says that if c squared minus b squared is equal to 4, prove that c and b can't be natural numbers. Now natural numbers are 1, 2, 3, 4, 5, etc. going up like that. 0 is not a natural number, and nor can a fraction or a negative number be a natural number. A natural number is something that you can point to and count, like 1 orange or 2 apples or 3 bananas, that type of thing here. So what I thought with this one was there are a couple of different ways to go. Well, let's start with our original statement, c squared minus b squared is equal to 4. Now, if we do difference of two squares with that, we could say, well, that's c minus b and c plus b is equal to 4. Now, since c and b are some kind of numbers, what we could do is we could split this up into two different equations, and we could say, well, c take away b times by c plus b could be equal to 1 times 4. And that would mean c minus b was equal to 1 and c plus b is equal to 4. Now if we add these two simultaneous equations together, we get 2c, because c plus c is c, and minus b and plus b would cancel out, and 4 plus 1 is 5, which when we divide by 2 leaves us with c equaling 5 over 2. But since c can't be a natural number, c is 5 over 2, that can't be a natural number, therefore we have a contradiction, and we've proven our statement. Now on the other hand, what we could do is we could say c minus b times by c plus b could be equal to 2 times 2. Now that would mean c minus b could be equal to 2, and c plus b could be equal to 2, which when I add those two simultaneous equations together, I get 2c is equal to 4, which means that c was equal to 2. And if c was equal to 2, that must mean b is equal to 0. Well, wait a minute, 0 isn't a natural number, therefore we have a contradiction, because we can't solve this equation unless we use either a fraction or a 0. And since neither of those are natural numbers, we've got a contradiction and we've proven our original statement. Now, give me a moment and I'll set this up again and solve it in a different way, which might be more to your liking. Okay, now I had a chat with Mr. Asanka, and what we both decided was that there might be another way to do it. So we sort of thought about this for a while, and we said, okay, let's take our original statement here and let's see if we can work it out mathematically another way. What about if we switch around the 4 and put that onto this side, and the b squared, and we put that onto that side? So we'd end up with c squared minus 4 is equal to b squared. Then we can factorize c squared minus 4, and that would be c minus 2, and c plus 2 is equal to b squared. Now here we've got a problem, because b squared is b times b, which would mean we'd have this. Now this is a bit of a contradiction, because we don't have the same thing on both sides. So b can't be equal to c minus 2, and b can't be equal to c plus 2. So there's our contradiction, so c and b can't be natural numbers. Now I guess the other thing you can do is say, well, b could be equal to c minus 2, and b could be equal to c minus 2, which leads us to say, well, if we write this around the other way, c minus 2 is equal to b, and c plus 2 is equal to b, which means we could get c minus 2 is equal to c plus 2, which means we have minus 2 equaling to plus 2, which is a contradiction that we can't have. So that means neither C or B could be equal to natural numbers. Alrighty, Year 11s, hope that helps, and if you have any more problems, hopefully I'll see you in class where you can ask.